Welcome back to FishBites Devlog for my fish simulation project. It's February 9th, 2022. But one thing that I've done is I've changed the initial genes of the fish to where the speed can actually be even zero. Notice this orange fish right here is barely moving. His preferred speed is 4% of his max. I set it to where a preferred speed could be 0%, just to see what would happen. Maybe a fish that doesn't move uses so little energy he lives for a while. The other fish bang into him and bang him, so he accidentally gets pushed into plants that he can eat. Who knows? So why not? If they die of extinction, that's survival of the fittest, and that's the whole point of the project, is to kind of let some little evolution happen on here. So anyway, but one thing that I realized I was doing is I was playing with this and trying to just kind of observe it and keep an eye on the population of the fish. Is I realized sometimes my population of fish was too small, and I would try to increase the population up to what I wanted the max population to be by increasing the number of plants. I would go into Global Data Manager. I go here to this max number of plants, and I would change the number from 300 to 400 or something, and then the fish would start pooping, and the poop would grow into more plants, and the number would slowly push up from 300 plants to 400 plants, thinking more plants in the environment would support more fish, which it does. Then I realized if I had too many fish, I might try to reduce the number of fish by reducing the max number of plants, so that when they got eaten, they didn't come right back as much. And I realized I was doing that so often, why not try to automate that with the code a little bit? So that's what I did yesterday. So I wanted to show that to you. In fact, you can see the results of it down here. I've got, for debugging purposes, I'm having it print some of its, every 10 seconds or so, it'll reevaluate the number of population, the number of fish in the simulation compared to the max number of fish in the simulation. And if the fish is below 80% of the max population, it's going to try to increase the number of plants to try to encourage more fish to be alive. That's what you see what's happening right there. Notice this says increasing the target number of plants to 350, and the current plant count is 341, fish count 36. Then about 10-20 seconds later, it bumps it up from 350 to 360, and the plant count has already gone up from 341 to 351 over the last time frame, and the fish have gone up. It's not a one-to-one correspondence. Sometimes the plant count keeps bumping up and up, and the fish population just gets stuck at 45 or something, and just will not go up towards, say, 80 or so. But it does something, and it's doing it for me in the background. I'm having to play with it so much. That's good. I also have it set to where if the population of the fish is 95% or higher of the max population of fish, then it's hitting that ceiling of that maximum. So maybe I'll pull the number of plants back a little bit, and then I'll do a decrease fish so what I did was, I never had this before. This was new. Target number of plants is 420. Max number of plants is 800. That's the absolute maximum plants you could ever have. I'm afraid if you have more plants than that, there's too many objects in the simulation. It starts to bog down. So I'm going to cut it off, say, at 800. But the target number of plants is what it's really trying to work towards. And that's kind of the limiting factor for how many plants are on the screen right now, 420. And that's the number that can change based on if the population is below 80% or above 95%, it'll adjust the plants accordingly. So take a quick peek at the code to see how that was accomplished. So in my ecosystem C# script, I've got a method called update max plant count. Let me clear out that fine there so it won't highlight. And that's an invoke, and it will invoke every 5 seconds. At the end of this code, it will invoke itself again 5 seconds from now. Instead of doing invoke repeating, I've taken to use this method for invoking. If I want something to repeat at the end of the method, it'll re-invoke itself another however many seconds later. And notice I do have this tied to the simulation speed slowdown factor global variable there also. So really it's only 5 seconds between update here if the simulation is running at full speed. But if I've slowed it down which I often run it at like 1/4 speed, it would slow this down to every 20 seconds, not every 5 seconds. So anyway, what does it do here? First thing it does, it checks to see if the current fish count is bigger than 95% of the maximum fish count. And if it is, then it will do this logic here. And it does check to see, well, we'll talk about this line here in a second, but what it will do is take the target number of plants and reduce it by 10. It will take that from global data, paste it into the static data global variable right there, and then just I print it to the console. The trouble with, at first though, I did not have this line right here, this if statement. And what would happen is the number of plants would keep decreasing and decreasing and decreasing, and if the fish were living too long and not dying off fast enough, it would stay too peaked, and it would keep reducing it down to where the target number of plants ended up being a negative number. In fact, and it just the number of plants never decreased enough. So now I'm using this line here to check the number of fish, or I'm sorry, the number of plants in the environment. So we're not going to take the target number of plants and make it way low, way lower than the current number of plants in the environment. But if the number of plants in the environment are close to the target, then it actually might be beneficial to lower it some more by lowering the target. So that's what that does. If it's not the 95% of the max fish population, well, then we check to see, is the current number of fish below 80% of the max number of fish population. And if it is, then we've got maybe not enough fish as we want on there. So we're going to bump up the number of fish by increasing the number of plants. So we add 10. The 10 is arbitrary. We'll just add 10 to it, see how that works. Seems to work pretty well. I've run the simulation a few times, let it just play out to see if it can kind of reach an equilibrium. So this lets the simulation be kind of intelligent and gear the right number of plants approximately to support the population size you want to support. Because we don't want a population that's way too small, because then there won't be enough interesting mutations and evolution happening there. We don't want the population to be way too big, because then the simulation bogs down. So this is how the simulation can kind of help the population approach the goal area of the population size you might want.